I bought this robot mower online as fault, but it was not fault, the battery was deeply discharged. I charged the battery separately and it works fine. The thing is, this robot mower didn't have a charger, so I bought a charger, 24 volts, 2 amperes, and I made a terrible mistake connecting the polarity in reverse here at the base, where I soldered this barrel jack, and I fried the peripheral loop circuit. I am fairly advanced in this repair until I decided to make a video, because I thought it would be an easy one, but I couldn't find any information on the internet regarding the peripheral loop signal. Now the whole assembly is taken apart, but for the sake of the video I will play it in reverse, the assembly process, so it will look like a disassemble.
Until then, nope, a nope, a nope, a nope, definitely nope, a nope, nope, a nope, probably never, ever, ever, ever.
And what can we see here? This is the motor which turns the blades, simple enough. 2 motors for the back wheels. This is a sensor of some sort. I don't know right now what it is. Could be a radar for obstacle avoidance. These are 2 sensors for the front wheel when they are lifted or not. It senses when you pick it up, and when it's picked up it stops turning the blades. And this is the battery which I extracted previously to charge it separately. And when I opened this mower, this is when I discovered it has a Bluetooth module inside. So yeah, we're going to see about this immediately, how the Bluetooth control works. So this is the inside. I don't know what this is. It's not connected to anything. I believe it's just some weight. It's a weight to press down the mower. I don't know how it detects the obstacle, because it doesn't have a spring bumper like the other one, the Parkside have. The other one, the whole outer shell is on springs, and when it touches something, the whole outer shell moves and makes some little contact there. But this one doesn't have a contact. It has a on-off switch right here, and it was off at the moment. You see there's a rubber gasket all around the perimeter and here too, and it is important to match these grooves into this cutout.
This is how the peripheral loop circuit looks like. It is very nicely done, covered in protective lacquer. This is the 24 volts input. This is the perimetral loop output. And we can also see we have a loop, perhaps for the robot to feel it when it is inside the dock, or maybe for the dock to disconnect the boundary wire signal, not to cause disturbances in the neighborhood. We also have the charging ports which connect directly from the 24 volts input to the mower for the battery to be charged. I have another lawn mower brought from Parkside, and it worked absolutely admirable for the last year. Of course, another one powered from the mains. And what I'm gonna do, the things I couldn't find on the internet, is measure for this robot the signals generated by the peripheral loop and have a base from where to start repairing my faulty loop circuit. I know the signals could be obviously different in frequency, but at least I might have a point to start from. This is the peripheral cable which came
with the Parkside robot, and it's an absolutely ordinary cable, multi-wire of course, and the gauge is about 0.75 millimeters in diameter, and I intend to use it for this mower too. Oops, a little spider. So my Parkside charger outputs 22 volts, which is perfect for our experiment, and I'm going to plug it in. And this is the Parkside base, and I've attached two leads to the peripheral loop, which is this one. I see. Yeah, I've made a little cover, like a garage, for the mower, and I'm going to use my fancy pantsy oscilloscope to check the signal form. I've disconnected the loop, you see, and I'm measuring only the signal with open loop. And what do you see? We have just a positive 20 volts with a little bit of ripple, so just positive, no pulses. And if I reconnect the loop reconnected, this is what we get: the same series of pulses at the 20 volts amplitude. I believe this funny shape is because the boundary wire, which is very long and behaves like an inductor and also like an antenna. So what I want to do next is measure the resistance of the loop and replace it with a simple resistor. See if the shape of the pulse changes to have a more accurate and better understanding of this signal. Yes, around 3 ohms. This is a 5 ohms, and I soldered some wires to it. And just as I supposed, the signal improved a lot. So basically this is a simple pulse. The duration of the pulse is about 120 microseconds long. Now, returning to the old boundary wire, I want to see if the presence of the mower inside will cause something. I'm telling it to go home now, and it's going to park itself. And it causes absolutely no changes to the signal. I brought the board in for a more detailed look under the magnifier to see if this is something obviously burned. Okay, now so power scrum here, a capacitor and the inductor. I took a look previously at the layout, and this inductor only contributes to the output for the charger, actually for the robot mower charging so there's nothing between the power input and the output but a simple rectifying and filtering circuit formed with this inductor and those two capacitors. But right away I can see something here. Yes, something definitely exploded here, but I can't figure the part number. Yeah, this is a pin here. Yeah, so I gotta figure out this part number. Okay, moving on. This is an unpopulated area, and we have a Wi-Fi. Probably another version would have been Wi-Fi enabled. Another unpopulated capacitor here. This is a SMD chip which looks similar to this one. I wonder if they are the same. Let me see. Yes, and I can even read the markings here. It says IAEQN. I'm not sure if there is an I. And we also have some sort of connector here. And the chip. Wow, it's upside down. 8817. An Atmel. Yeah, it's a microcontroller. And with a quartz. A little bit of reverse engineering later. I figure out that this chip outputs a voltage which goes over there, which reads BVCC, which means bus voltage. So this, I believe it's a regulating chip giving some sort of bus voltage, and this bus voltage is used to control this MOSFET, I believe it is, which receives command from the microcontroller, and it is this one which creates the pulses going through this inductor, another two small inductors, some sort of capacitors here, and directly to the boundary. Yes, let me give it some power and see what voltages do we have. If we have voltages around the microcontroller and this area here, and maybe we have some signals for the small loop inside the dock. For this I use my homemade power supply, which is set to 22 volts and maximum is 250 milliamperes. In case something is wrong, terribly wrong, so it won't fry the other components. Okay, now let's turn it on. It draws approximately 15 milliamperes, which is good. It would have been great if I had a thermal camera to see if something heats up, but it doesn't hit at 15 milliamperes, to be sure. No, this one not. This one not. Let's see if we have some voltages. For example, the input voltage. Nah, damn this coating. 22 volts. This is the input voltage. The coating is to blame, not making good contact. Towards the charger, yes, there is. Not great. Let me see here. Nothing. So right now, after a lot of poking around, I understood this. This tiny little regulator outputs here at pin 6, and there's nothing, and the input is on pin 6, 5. The input voltage is this, the output voltage is this, 0, and it goes right there, BVCC, which is 0, also 0. The other one, the other regulator, the input is here at 5, and we have input, and the output is here, and there is no output, which is linked here at plus 5 volts. We can see 0, and here at this connector here plus 5, but we don't have, and inside the circuit it is connected with this capacitor which powers the microcontroller, and this is the plus, and we have no power to the microcontroller. So basically we don't have any sort of power. This is obviously fried. This is not obviously fried, but it might be fried because it doesn't output anything. I don't know if this output is linked to this one. I doubt it. And I'm going to search for the component and order, and I will replace them and see what happens next.
So I went online and searched for my component, typed in the code I saw on the package, and this Amazon linked was lucky for me. And yes, there is my code over there, and the same without the I in front of it. So yes, it's the same marking. And basically this is the component we are looking for, MP2459. Yes, it's a 0.5 amperes 55 volt step down converter. Yes, is a regulator. Let's check the datasheet. Yes, the schematic matches perfectly the board. It's the same layout as my board. One shopping site that I use, which is very good here in Romania, which is TME, some sort of Mower or Farnell. And yes, this is the thing I'm looking for, and even the marking is the same. Yeah, the datasheet is the same. It's the same chip, and I hope it's the one I'm looking for. Now let's buy it. $5, 5 pieces is €1, 1.1 euro, but that's too much. 5 pieces. Let's try 10 pieces. Too much. Let's try 5 pieces. 5 pieces less than €1. Yes, I'm human. And moving forward to the buying process. Bingo, €12 later, my purchase is complete. In 3 seconds time for you, the parts will be ready to assemble.
And 3 days later, the spare parts arrive. And that's precisely the 5 chips I ordered. Yes. And this is the part number. And because I do not have the tools to make the replacement, the small SMD soldering, I have to go to a shop called Laptop Repair to ask them to do this swap for me, of course in exchange of a fee. The board returned very fast. In your word, in my word, it took almost 4 weeks to complete because of the holidays. But anyway, this chip here and this one here are replaced. If we take a look under the magnifier, yeah, this one is a little botched because, as you saw before, the trace was exploded and they had to put a little wire to replace the trace. They soldered the controller in reverse and I had to go back and tell them to solder correctly, but they said that it was correct because the board was misleading due to a line over here or there. But the modern boards are very misleading in all the ways. It's very hard now to determine the markings, the components marking, and this is the other chip. Yes, it looks relatively nice. And all it's left now to do is to test it under the power and see if all this trouble was worth it. The power supply is set and it is controlled now with this computer software, which is nice, not very advanced, but anyway, perhaps we'll be able to see some evolution of the voltage and the current here, and let's get started. Well, now we have to measure the voltages to see if the replacement was any good. So I'm going to start the power supply. Bam, started. And we have 4 milliamperes current. Okay. Let's find the negative rail over there, and let's see if we have BVCC. Bam! 17 volts, that's awesome! Awesome! 5 volts for the microcontroller. 5 volts, awesome! And the current draw is minimum. That's great. Let's see if now everything is connecting, is nothing exploded. I'm going to connect it to the mower base itself and see if it generates the signals, and then we are going to measure something just out of curiosity. Right, so this is the base of the mower, and this is the board. It has a button here and 2 LEDs on the back, and I'm going to connect this flat cable to them. Yes, and here is the local loop. We're gonna see in a minute what it is all about. What the fuck? And this is the external loop, which has here a connector. And this is the power. The measuring instrument, green. I'm going to measure the correct voltage because, you know, this is why I busted it. I connected it in reverse. Yep, 24 volts, 25 volts almost. And you notice what? You see what here? You see the positive? The positive is the blue and the negative is the brown, which fooled me because this builder connected them against the logic. I'm plugging it in. Alright, I'm going to measure again. This is the battery exit output, yes, correctly. I have a negative here and BVCC here, 17 volts. 5 volts for the microcontroller I have, and let's turn it around and see if, yes, the LED is blinking. It was dead before, obviously, and is blinking, signalizing the boundary wire is broken, and of course it's broken because nothing is connected here. And this is the command from the microcontroller. It's a very strange looking signal. Very, very strange looking signal. Very, very strange and complicated. What the hell do they have to do it so complicatedly? And this is a button which changes the pattern for a different signal in case your lawnmower interferes with a neighbor's. So if I change the pattern to signal 2, let's see what's the difference. signal 2, signal 1. Well, the third pulse comes a little bit closer. Signal 2, the third pulse goes a little bit away from the first two pulses, like a airplane transponder. Exactly like an airplane transponder. You see signal 1, I press here, signal 2. And the shape of the signal is totally different, you see? 50 Hertz. Let's save this waveform. And signal 2, I don't see any difference. Signal 1, signal 2, I can't see any difference. If I probe again the shape of my microcontroller, but if I probe the output just out to the loop, aha, it's kind of the same shape but inverted. Now I understand. Before I put the little screws back in, I have to do this. I have to redo the coating with the lacquer where I scrape it. Yes, so just a second please. And for that I have, you see, lacquer in color, which is no color or transparent. Shake it baby, shake it real good. Yes, and I take this brush, this power regulator which was replaced. It's good to have it all protected because it stays outside all the time in the weather. And you know what the corrosion might do to such tiny board and tiny components. Okay, let's put it back in and it will cure naturally, it will dry naturally. So I'm going to take a picture and put it right here on the screen. What kind of component this MOSFET or transistor is. Let's turn it off. Finish the assembly. And check the damn thing in the real world. And this comes in like this. Nice. Now let's take it outside and give it a taste. Now the mower has these markings here, so one end of the wire goes underneath the base and underneath the base plugs into F front, and the B, no, what the hell, negative and positive, yes, so F front goes underneath the base and B goes out to the perimeter. See, well, this is how I'm going to do it. I have a steady blue, you see, yeah. Let's start by placing the mower into the base. And what I'm going to do now is turn it on. Let's see if it starts. 3 hours. Okay. Start. Whoa! Yeah. So my robot is connected, and let's turn it on. How do I turn it on?
So I got my lawnmower working again. Another robot, another reason for my little doggy to bark at. 2 voltage regulators fried because of accidental reverse polarization, but luckily no other component, especially the microcontroller, was damaged.
Houston, Eagle has landed. Roger, Tranquility. We copy you on the ground.